All right, guys, at this time, I'm going to need Dave and Matt to lower their voices for my upcoming presentation. All right, now that Dave and Matt have quieted down, let's start my project. Good afternoon, class. I'm doing my remote sensing project on Newtok, Alaska, and my name is Chris Gentile. Now to answer the question you've all been asking, why Newtok, Alaska? Well, I'm going to break it down for you. There's 4 native villages, Shishmarif, Kivalina, Newtok, and Koyukuk, that were all found as serious threats to flooding and erosion. These are all been caused by glacial ice that's been melting. Newtok in particular, the Ninglik River, which lies south of Newtok, has been rising tremendously and causing the shores and the coast of this village to erode away. You can see by these pictures is the actual riverbanks, while the water is low, that's destroying this town. This is important because the residents of Newtok do not have the funding to repair the existing damages caused by the previous floods and increasing erosion. Villagers are abandoning homes that their ancestors have occupied for numerous years before and have been forced to relocate with limited funds to continue their daily lives. Now, how is this project relevant to remote sensing? Well, I'll tell you. Remote sensing can provide insight by calculating how much water has covered the land surrounding the village over an amount of time. In this particular instance, I chose 2 satellite images from 2008 and 2019, both in the month of August, to prevent bias. Remote sensing can also help us determine the amount of change in land use, and land cover with supervised and unsupervised classification of my study area. All right, the first article I used for my lit review and for my topic is about ecological modeling in Alaska. It's all about the importance of tree and species level interactions with wildfire, climate, and soils in Alaska. And it came up with University of Virginia came up with a forest model to predict the effects of climate change in interior Alaska. And this method allowed for the simulation of tree growth, lifespan, and regeneration of marked areas of forest. It's very interesting because my study area didn't have forest, but it had a little bit of shrubland, so that's why I use this. The next article I used was about detecting soil freeze and thaw onsets in Alaska using SMAP and ASCAT data. They used microwave sensing for measuring and gathering information about the thaw and freeze state of soil near the surface. I found this interesting and it also relevant to my actual project because it was all about thawing and melting, and that's the main point of my project is ice melting and causing sea level to rise. All right, my last article was about linking vegetation cover and seasonal thaw depths in Alaska. All the data that was gathered was through hyperspectral imagery with an overall map accuracy of 85%, and then was put into the Quantum Geographic Information System, QGIS. We also talked about that. It's really cool. And this was relevant because this was showing where all the soil nutrients are the highest, so farmers who are being relocated from Newtok to their new area can find the best place to plant their food. All right, so I did my supervised and unsupervised classification through an orthographic image that I got off elevation.alaska.gov. I actually emailed the Alaska GIS team and they sent me this link and I got this. The ortho image that I downloaded, it came with 3 bands. It was collected from a Cessna 170B aircraft in 2015, which is a picture of that plane right down there, and with a Nikon camera, that is the exact same one they used. It also had a lens on it. I think it was a 24 millimeter lens. So it got in there pretty good. It's 9 centimeter ground sampling distance. As you can see from the picture, that's you can zoom in a little bit farther than that, but that's about the extent. But it's pretty high quality. All right, so here's the result of my ISO cluster classification. All I did was after I downloaded that ortho image and put it into Arc Pro with its 3 bands, I just ran the ISO cluster tool and I got this. It wasn't as pretty as this. I had to reclassify with the help of someone who isn't colorblind, but I got it to ultimately work out. The problem I had here is that you can see at this square is that is actually water and it is marked as barren land. But the problem is that orthographic image, there's different reflectance of different parts of water on the image, so they were showing up different no matter what I did. All right, since my orthographic photo can be zoomed in to centimeter resolution, this ISO cluster tool worked out very well. As you can see, as I zoomed in on this area here, all the black is buildings, and the black roads got actually marked as urban, how it should be. Same with the airstrip on the left side there. It also picked up some sediment, as you see in the left picture, in the center pond, that little circle like halo at the top. That is dirt sediment coming from the water runoff in the original ortho photo, and it picked that up. So really good classification. All right, next up is the supervised classification. In order to run this, I used that same orthographic photo that I uploaded with the 3 bands. Then I used the Wizard supervised classification tool, and I did random trees is how I did this. As you can see, it's not as accurate as the ISO classification. It started marking a lot of urban areas as just straight water because of that problem I said before, as the reflectiveness, everything kind of looks like water or ice. And if you look at the buildings there, you can see how the roads are all water, the landing strip is all water. It just didn't pick them all up. For sampling points, I did about 30 for each classification. I probably needed to do more, but this is what I got. All right, to continue from the previous slide, on the left we have the zoomed in image of the original ortho photo, and on the right you have the supervised classification of the same area from the previous slide. You can see, even though the roads were marked as a sampling point as urban, they showed a blue on the right side, as in water. You can tell some of the actual houses did not get picked up as urban. They also got picked up as water. You can see the reflectance of the water shows up a little bit different, and the road and that water to the right almost look the same exact color. So that's why it did it. All right, for my third map, I decided to use those Landsat images and to do a minus for change detection. First thing I did was got 2 Landsat images off USGS, one from 2008 and one from 2019, both in the month of August, so the month would be the same time of year. I took a little study area, as you can see on the far left photo from the raster, that little yellow square, that's where Newtok is. The second photo in, the middle one, is the actual Newtok of my study area. I extracted by mask. And then when I extracted by mask, I ran an ISO cluster tool on each one. That's the far right, and you can see how much different it is. 2008, there was a lot more grassland, and less barren land. But then you see 2019, the water level has been rising, and a lot more of that grassland has disappeared. Once I did that ISO cluster tool, I reclassified again to just 2 classes so I could have land and water, 1 and 2. The top is 08 and the bottom is 2019. I ran the simple minus tool on Arc Pro and I got the image to the right. The -1 value is all that was lost. So all this black down here on the coast there, that is all lost land that turned to water. The 0, the middle, that is all stuff that did not change. In the lighter color, the 1 value is all gain. So you can see it gained maybe a little bit of grassland, but it lost a lot of its land on the coast right there on Newtok. All right, the last map I did was of LiDAR. Unfortunately for Newtok and most of Alaska, I could only find 1 date of LiDAR, which is fine for this, but I wasn't able to do a change detection because of the 1 date. This one is from 2016, so only a couple years ago. As you can see, the highest elevation is on where the actual village is, where they live. You can see on the right there, all the little where the buildings were. You can see the whole landing strip. But outside of that, it is just sinking. So, all right, that's it. This is the conclusion. Uh, Hopefully this project will shed some light on the effects of climate change to those native Alaskan villages I talked about in the beginning. Some of the challenges I got here were creating areas in land cover due to the lack of high spatial resolution images for the state of Alaska. I got lucky with that one orthographic photo, but it's very hard. There was nothing else. There's no NAPE imagery for Alaska because it's so high up there. Retrieving more than 1 year of LiDAR, like I said in the previous slide, that's difficult, but it would have proved helpful. And also the supervised classification showed a lot more error than the ISO. So maybe if I took a little bit more time with more sampling points, the only problem is having the time to run that, because that classification took a couple hours on itself. But that's it. Here are my references if you are interested. Is there any questions?